Let's look at this application problem where we have this triangle. Well, we have multiple triangles in this picture, but we're going to have to use the law of sines to help us with this. Because if you take a look at this diagram, they're asking for us to find h. Well, with all of the triangles that are in this picture, if I look at the triangle BCD, I only have an angle in that whole entire triangle. Well, technically two, because I have the right angle. But that's not enough information to help us find a side. If I look at the really big right triangle of ACD, it's the same exact thing. I have that 25-degree angle, but that is essentially it as far as that big triangle. So we really have to use that small triangle ABC in order to help us then figure out what H is. So notice that with our problem, if the triangle ABC, we are given the side of AB to be 238, we're given angle A to be 25, notice that I actually can figure out this angle B because it is right next to that 29-degree angle, and together they're forming a straight angle. So I'm going to subtract 29 from 180, and that tells us that this angle right here is 151 degrees. Now that I have 2 out of the 3 angles of that triangle ABC, I can go ahead and I can find this third angle C by subtracting now 151 and 25 from 180, and that is a 4-degree angle. With us now having a lot more information of that triangle ABC, we have enough information to set up a law of sines, and then that's going to allow us to get a piece of another triangle, either the right triangle of ACD or the right triangle of BCD, and that's then essentially going to help us find what H is. Let's do this. Let's find the side that is across from angle A. So I'm going to call that whole entire side, which is BC, I'm going to call that little a. And I'm going to use the law of sines to set up an equation. So I'm going to have a over the sine of 25 degrees. And that equals, because the only side that I have in that triangle ABC is 238, I have to use that. It is across from angle C, which we calculated to be 4 degrees. So here's my setup. I can start solving for A. So I'm going to cross multiply. We'll have A times the sine of 4 degrees equals 238 times the sine of 25 degrees. I'll divide by the sine of 4 degrees. And once again, you can type all of this into your calculator because what I'm finding is not actually the side that I want. Even though my final answer says to round to the nearest 10th, let's go ahead and round maybe a little bit farther out. Let's round 3 decimal places. So hopefully when you type all of this into your calculator, we get 1,441.918. So once again, I just rounded a little bit farther out than the 10th because that's not my final answer. I'm going to have to use this rounded value to help me with the next part. So having as exact as possible is kind of the key for these problems. But notice that now that I have that, I have the hypotenuse in the triangle of BCD. And so now I do have enough information in that right triangle to do right triangle trig. So I can think SOHCAHTOA. I can use the 29-degree angle. H is opposite. And like I said, A is the hypotenuse. Well, opposite and hypotenuse means that we can keep using sine. So the sine of 29 degrees equals the opposite side, which is H, over the hypotenuse, which we just calculated to be 1,441.918. To get H by itself, I'm going to multiply both sides by that 1,441.918. And so then, once again, we can carefully type all of that into our calculator. And now this time we can round to the nearest 10th, so to 1 decimal place. And that ends up being 699.1. And that is my answer.